My next thing was a question about this material that you're trying to create these negative energy states. There's a couple different things. We were talking about some of these metals and stuff. I recently came across an article of what they're doing at the University of Rochester, and that they're basically taking metals, and I'll share the link in the chat, and they're doing laser etching of the metals, and they basically create a microscopic pattern, or they basically turn the metal into a metamaterial by etching it with a laser and etching certain patterns into the material. There's a guy I mentioned before, David Cohen, Nathan Cohen, I think. He owns Fractal Antenna, fractantenna.com, and they have a bunch of contracts with the Defense Department on some of these devices that use fractals, fractal electronics structures, printed fractals, to basically, because they interact with the electromagnetic waves in enhanced ways, kind of like metamaterial would. And that this type of laser etching of these types of metals is a way to create metamaterial structures that are much smaller than the scales of these. You know, you have to create a structure that's smaller than the scale of the frequency that you're trying to manipulate with the nanomaterial, with these sort of metamaterials. So these this is an interesting method that I've come across. Posted the link in the chat to this, but they talk about warp drives, right, and wormholes and stuff like this, right, in the article. A very interesting video too, illustrating the whole idea of like what are called surface plasmon polaritons. It's similar to it's a polariton, but it activates only on the surface of materials. And we were talking about these ideas for really low power craft that are able to, you know, function with light in ways that are really advanced. I think this is the kind of materials we really ought to be looking into more deeply, and I think this is indeed what the government's researching with their studies, because I keep finding I found that terahertz research group at Wright-Patterson that was connected to that. They're doing some type of top secret research at Wright-Patterson with the terahertz team there, and I know that those guys are experimenting with you know, similar types of materials. But I just wanted to interject with that, to put that on the table with this talk of the negative energy states and the types of materials that we might want to look at and look into.
Okay, so getting back to the experiment that Bill actually just enlightened me on, when we're doing the impulse parallel plate capacitor experiment, I think it might be interesting to see what happens when we add either permanent magnets or electromagnets. Probably easier to just put on permanent magnets on either side and see if there's any added strength to the effect, or whether, you know, the polarity matters, or it'll be a very interesting thing to look at. So I was thinking of probably getting a set of disc-shaped magnets with a hole in the center for the leads, and you just put that around a disc-shaped parallel plate capacitor, and you know, impulse it with crazy amounts of energy, which Jeremiah is going to be coming down here to the lab, and we're going to be working on a whole bunch of these experiments, and I hope to do this a lot more often. I hope you guys are enjoying yourselves. One second, I'm just going to try sharing the screen. We have a little flyer that we were working on the other day. Can you guys see that?
Good.
Oh yeah, so it's just a nice logo. I thought we'll call this the Alternative Propulsion Engineering Conference, because what we're doing here is we're trying to concentrate on the engineering side of anti-gravity, how the nuts and bolts of what actually happens. So yeah, the first Zoom conference is today, and yeah, whatever, maybe in the future we could have schedules and
yeah, I think things are going pretty well. I'm excited. I'm excited to see all these folks here. I appreciate Bill and Paul and Ron, and I don't have the whole list, Tania, and, you know, I mean, we've got a pretty good turnout, you know. And it is exciting too, to be able to kind of focus more on engineering stuff, you know, things tend to get lost in the mix otherwise, but.
Right. And that's why I wanted to concentrate on the engineering side of it. And I thought it was actually pretty amazing that the Alternative Propulsion Gmail account that I wanted for this conference email was actually available, like Alternative Propulsion at Gmail. So we're getting synchronicity here, and I'm loving the name. And that's the goal. What do you guys think of it?
Okay, good. Hello? Am I here? Am I hearable?
Yep, you're hearable, Ron.
Yes.
I came across something I sent out. I don't know how many copies. A lot of people go to phys.org every day. I don't know if they use it or not. If you go to phys, it's for physics, phys.org, there's a new quasi-particle. And it has to do something with negative mass, negative energy. It's a new quasi-particle. It was on phys.org 3 days ago. And they use iron and selenium. If you want to, I will email it to you, because I'm running low on batteries. In about less than 10 minutes, I will be without phlogiston. So, but anyhow, it's about 3 days ago. If you type phys.org quasi-particle selenium, it should come up on Google.
Mark, can I ask you a basic question?
Yeah.
My basic question is, I don't know too much about some of the guys in this group, and you guys are apparently building or trying to build hardware. What do you do for a living? Is it part of your job, or what? You know, I'm looking for possibility of an organization, information, or what's your motivation? What do you intend to get out of all this? And what happens if something happens where we break out with some levitating devices? I know it's going to happen. People are going to go in different directions, and it could get messy. So give me an idea of what's going on. Do you, the space research company, is it your company doing for your dollars, or is it just something you put
Okay, so let me explain that to you. So basically, this is a hobby that really took off. There is no LLC or company set up, you know, under the name Falcon Space. I chose Falcon because my last name is Sokol, which in Russian means Falcon. And, you know, Falcon Space, it sounded really cool. And I used the logo from my actual business, what I do for a living. Here, let me disconnect over here, and I'll show you what I do for a living. Does anyone here have a Prius?
Have a what?
A Prius, a hybrid car.
No.
Well, hybrids are about saving the planet. That's what we're trying to do. So this business I started about 8 years ago with absolutely no knowledge. I've never really even graduated high school, but I'm an autodidact, and I learned all this stuff on my own. When I replaced a battery in a broken Prius, I realized that there's a massive market for it. And I figured out how to refurbish hybrid batteries, which are basically nickel metal hydride batteries, and then I quickly realized the equipment to do so didn't exist, so I had to build it myself. So this machine you see in front of you is called a prepper. Basically what it does is it charges the battery rapidly in series and discharges it slowly in parallel. And the reason why you have to discharge in parallel is because nickel metal hydride has a voltage drop when it reaches full charge. It's similar in build to a hydrogen fuel cell. I actually had a guy once who bought some scrap nickel metal hydride cells in order to take them apart and build hydrogen fuel cells out of it. So I thought that was pretty cool. And it also recycles the energy back into the grid. So it's all about recycling. This company is basically a recycling company. And then
well, I guess what I'm saying is where are you getting the bucks to do all these things? You know, pieces of hardware, it's kind of costly. For example,
okay. First of all, pieces of hardware are not that costly. Pieces of hardware are sometimes hard to find, and what you think about, you bring about. So if you want it, you got to think about it. That's the way the world works. check out this.
Nah, I don't think it does.
It does work that way.
Sounds like a
Beg to
contest.
differ.
Oh, okay. Hear this story. So basically, I needed a traveling wave tube amplifier. I thought that was the best way to create the microwave energy necessary for the experiment. And I quickly realized that they are very hard to find and that most of them are broken. And I found some guy selling one on eBay, and he promised to give me a full refund if it was broken. This was after I already had a broken one. And he gave me a full refund and didn't even want me to ship it back. So then I opened it up and I realized that the low voltage side for the tube was broken. Fixed that, and the thing works. So it was a much simpler problem, because when you powered it up, it didn't turn on at all, which for engineers is the best thing ever, because that means it's probably a simple fix.
Okay, Mark, the reason I'm asking the question is that, you know, I've been in a lot of aerospace companies. I've been in the government. And when we made the Morningstar Energy Box, the cost of the parts by itself was like $300,000. And the total cost that we spent was like, I would say almost $750,000.
Oh, wow.
And, you know, it was, we put this thing together as a pretty serious device. The first approach was to make it a magnetic motor, but that didn't happen because, you know, I had heard all the great things that the Russians did with Goodman and company. And it turns out that when we did our thing, we ended up with some weight loss as a afterthought. And when one of the Russians went to the meeting that I gave, he suggested that half of the things they suggested they didn't do, and we were more successful than they were. So, and then I look at Podelnikov with his spinning disk problem, and I looked at the pain and the anguish that NASA Marshall went through to get that, and there was a serious effort on their part. They never did go that far. Well, they had a 6-inch or an 8-inch disc that worked. When they got up to 12 inches, when Ning Lee was there, they ended up with a crack, and you're not going to spin that up at 3,000 RPM. You have pieces all over the place.
No, they weren't doing the experiment. They were doing the impulse experiment.
No, I'm talking about the spinning superconductor part of Podelnikov's experiment. He ran 3 experiments. 2 of them with the spinning conducting disc, and the other was the gravity pulse device.
You're talking about Pakhanov, right?
Yeah. Maybe I'm not pronouncing it right.
We all have trouble pronouncing his name, to be honest. It's not just you. It's not.
Well, he made a confession later on that it would have cost about $1 million to make one of those superconducting discs.
I tend to disagree, and I think Jerimiah is probably the best example of that.
Oh, really?
Yeah. I mean, Jerimiah needs to turn on his camera and start showing you some of the shit he built out of trash. Like he would go through the dumpster and he pulled out a broken laser printer. Do you know what's inside of a broken laser printer?
Laser.
No, there's high voltage components. You got rectifiers, high voltage capacitors, all for free.
Oh, geez. I just threw away one.
Yeah, basically my prerogative is, you know, I have a long history in the industry. So I worked for a motor winding company, a battery restoration company, a calibration company. For 8.5 years, I've got my CCT certification, and spent a lot of time really getting methodical about these scientific tests because I have a very analog, almost robotic approach. You guys know Data from Star Trek. I have that kind of approach to this research, and so I guess you can consider me the resident skeptic and calibration technician. But my approach to this has been to take a lot of these really fantastic claims from patents. Boy, do I love patents, and from various other documents throughout history, and really try to test them. And so far, I've been doing this for 21 years, and I haven't really received a whole lot of tremendous results. For the most part, I find that there are many measurement errors that come up. And because I think a lot of experimenters, even those qualified in universities, that have done their due diligence in the field.
Time out.
Go ahead.
I have heard so much BS from guys that were replicating the spinning disc problem.
Yeah, amen to that. There's a lot of errors.
the argument was, hey, I should get results with my 6-inch disc or my 4-inch disc at 800 RPMs. And they go do it, and nothing happens. And the bottom line is that sometimes you got to go through a threshold. And this Podolnikov's experiment and this guy's replication is a separate experiment.
Mm-hmm.
So the bad thing about it is when you start getting negative words where, hey, this guy's stuff doesn't work. Why would we want to look at his gravity pulse device?
Right, exactly. That's why we set up this conference, so that you can literally see the experiments as they're being built and point out any errors.
Are you guys going to put? Wait, are you guys going to put something like that together?
We are working on it.
Like that together. That's pretty simple to put together.
Well,
I mean,
what I got to say is, be careful going backwards, because the backwards will get you the Hutchinson effect. You got to push one in.
We're hoping for John to be on here. He has a lot of interesting experiments, and I have all the equipment right here in the lab to try all of it. And getting back to what you were saying about the where the money comes from, so far I've been using as very limited amounts of funding to purchase the equipment behind me and all around me, actually. Jeremy Riss is another example of what you think about, you bring about. He kept on searching on Craigslist for a lab that was going under, that was selling out. And he went and found this massive power supply behind me. And then when I saw that, I was like, holy crap, get that power supply, because I can use it to power a Klystron, which I already knew where to buy. And we can try the Alzafon experiment in high power. And that they gave it to him for $50, which is less than the scrap value of the copper. So you can get stuff for dirt cheap if you think about it. And if you want
MIT flea market, there's Brown University, a lot of these I live right in New England, so we got Harvard, MIT. They get new equipment. They have really well-funded schools with really well-funded labs, and they're constantly replacing and getting like brand new equipment all the time. So they have these fleas like 3 or 4 times yearly, where they get rid of old equipment at a pretty good price, reasonable prices. But nothing beats going on like Craigslist and the Facebook yard sale groups, and I just type in laboratory equipment, and I do that like pretty much every week.
So you're from the Boston area then?
Yeah, I find a lot of stuff around here. Mark,
where are you from?
So I'm in Hawthorne, New Jersey. We're the SpaceX of the East. SpaceX is in Hawthorne, California.
Okay.
So anyways, yeah, I got all this equipment pretty cheap, and I was using, of course, funds that I got off of the from my day job with the hybrid batteries. And we also got a couple donations recently. We got a pretty sizable donation, and that's going to sponsor, we're going to rent a house and have a couple engineers come down here and actually work on these experiments. If anyone's interested in coming down, we are an open source lab. I do not believe in secrecy in this field. And I'll tell you why. It's because there's nothing to be gained through secrecy. You literally should just put everything out there, and the industry that will open up on the other side of anti-gravity disclosure is so large, you're guaranteed a part of it. So you don't have to worry about money in the future, because it's going to be an industry that will literally transform humanity.
Well, Mark, I understand that the internet's a technology leverage to the rest of the world, but I disagree with what you're saying. And I could give you examples about Ning Li and so on. But, I guess the question here is, I appreciate what you guys are saying and what you're telling me, and I have somewhat of a calibration where you guys are going. Can we go back to the original objective here, to what you guys are doing and how far you've gone so far?
On which experiment?
The Alphason experiment. Apparently you're saying to me, I've got the impression that you've done some duplication of his work.
Oh yeah, okay, so let me show you the entire Alphason experiment. So this is the setup right now, and we are going to change it soon.
Guys, I have to, I promised my wife that I would eat, so I have to bail out for a little bit.
Oh, okay. 1 second. Before I go, for Mark.
Oh, well, no, I don't think it's ending. I just have to run out the door. So I just want to let you know.
Just
Okay.
put the settings so a speaker view for everyone. I think you got it right now.
Yeah.
One second. Okay. Can anybody hear me?
Yeah.
Can Mark hear me? What I wanted to say, I'm low on battery. I'll be out of here. But for Mark, are you familiar with testing a AA battery by dropping it? Have you ever done that?
Yeah, that has to do with the alkali system. Basically, an alkaline battery goes from basically being a solid to being a liquid when it's discharged.
Oh, is that what it is?
Yeah, so there's water in there that
Okay.
Yeah.
Because I was wondering, have you ever weighed your battery charged versus uncharged?
It weighs the same. It weighs the same.
Does it? Okay, because I always
The
wondered.
difference in the drop test, and the reason why it works is because the hydrogen and the oxygen are inside the anode and
Okay.
cathode, and then they combine together to become water when it's discharged, which is the opposite of a lead acid battery that it becomes water when it's fully charged.
Because I have one material that when you get it cold, it goes liquid. It goes to liquid. So I can't use it. So, okay, well, it was good talking to everybody. I'm going to, before I crash here and lose my computer stuff, see you next time. And good to see
Hey, Ron, before you run, I have just one last question for you. Any way to contact you? I have some contact information for you. Is it okay if I send you an email and try to get some info on maybe how to test some of these other materials that you talk about in your patent, maybe where to find them or how to set
well,
up?
the trouble is they were at one time made. In your old capacitors, they used the term was hollow wax. I don't like to use the word hollow wax because what I use, hollow wax was at one time used widely in capacitors and transformers, and then they were regulated out of existence. But yeah, beam me an email and I will answer what I can. So,
That'd
okay.
be awesome. Thanks. All right, man. Have a
Can you
great
tag me in that email?
The 2020 Woodstock. Nice meeting everybody.
Okay. Thank you.
Ron.
Thank you,
Thank you,
Ron.
Ron.
Okay, good.
Thanks a lot for joining us. You were very informative.
Welcome.